In this lesson, we're going to be looking at KC and going through some exam type questions. Right, grade 12, so let's look at our first example. We are given a 2-hydrogen iodide goes to hydrogen plus iodine, and we are told the equilibrium constant for the forward reaction is 0.02 at 725 Kelvin in a 1 decimeter cube container. At equilibrium, is found that we have 0.04 moles of hydrogen iodide is present in the container. It says calculate the concentration of hydrogen at equilibrium. And then it says calculate the equilibrium constant of the reverse reaction. Okay, we'll worry about that later. Let's do this bit first, okay? So we know that Kc is the concentration of the products, over the concentration of the reactants, okay? And in that case, that is going to be the products in this case are hydrogen and iodine. So it's going to be the concentration of the hydrogen, concentration of the iodine, over the concentration of the reactants, which is your hydrogen iodide. That's the concentration of them. And remember, whatever that number is in front comes to the power, so it becomes squared. So that is your Kc. In that case, in this case, we are told that this constant is 0.02. 0.02. And it says at equilibrium, it is found that you got 0.04 moles of hydrogen iodide is present in the container. Calculate the concentration of the hydrogen. Okay, so what we're going to do is we're going to have to use a table. Now, grade 12, there are lots of different ways to label this table. I use SUMEC, which is start. I'll show you what I mean by this in a minute. Used, made, equilibrium. I'm not going to write out the whole word. And obviously concentration, which I put in square brackets. So if you look at the first letters, it got SUMEC. So I tend to call this the SUMEC table, But there's a lot of people that use SHREC, for example, which is start, change, equilibrium, concentration. It doesn't matter. The whole point is as long as you've got a table that you're using and you understand. And what we are going to be doing is using this table to understand what is happening to our reactants and products during the reaction and until they reach their final state. Okay, so what does it say? It says that at equilibrium, we've got 0.04 moles of hydrogen iodide. So we've got 0.04 moles of hydrogen iodide. And it says calculate the concentration of the hydrogen. So what we want is X. Okay, the concentration. Now the nice thing is, remember that in order to get the concentration is number of moles over volume. But in this case, the volume is 1. Therefore, whatever this concentration is, we're taking the concentration, we're timesing it by 1 to get the number of moles at equilibrium. So therefore, this is going to be X as well. Right, now what do we need to realize? We need to realize that since they don't tell us otherwise, we start with 0 hydrogen and 0 iodine. Okay, we obviously haven't used up any of that. And we have made, if we ended up with X hydrogen over here, then obviously we made X hydrogen. Now the ratio of hydrogen to iodine is 1 to 1, which means that we made X moles of hydrogen, we must have made X moles of iodine, and therefore we ended up with X moles at equilibrium. And finally, that means that we have X moles per unit volume. In other words, because our concentration has to be X because the volume is 1. Right. Now let's look at our hydrogen iodide. Obviously, we didn't make any hydrogen iodide, okay, but we did use up hydrogen iodide to the point of it being, what did we use up? We used up X. So obviously we started with we started with X plus 0.04, right? And obviously our concentration over here is going to be 0.04 divided by 1, which is 0.04. So we can use this here in this formula to find out what our concentration of hydrogen is at equilibrium. So let's do that. We've got 0.02, which is our value for Kc, is the concentration of hydrogen, the concentration of iodine, all over the concentration of hydrogen iodide, all squared. So the concentration of hydrogen we know is X, okay. The concentration of iodine is also X, remember, because concentration, number of moles of volume, it's 1-to-1 ratios, that's X. The concentration of hydrogen iodide they gave us, it was 0.04. They gave us a number of moles, but remember the volume is 1. And don't forget to square this. And this all equals 0.02. So we're going to then take this across to the left-hand side. And therefore we've got 0.02 multiplied by 0.04 all squared is equal to x times x, where x times x is x squared. So we pop out our calculator and get 0.02 times 0.04 squared is going to give us 3.2 times by 10 to the negative 5 is x squared. And then we square root our answer, and we get that x is equal to 5,66 times by 10 to the negative 3, and that is the concentration. So that's moles per decimeter cubed of both the hydrogen and therefore the iodine. So that there is our concentration at the end at equilibrium. Okay, not too difficult, hey? Admittedly, it seems difficult. You need to think it through, and remember, grade 12s always let whatever they want us to find out be x and then work backwards from that, and then just take it baby steps. Now let's look at the next part of the question. The next part of the question says calculate the equilibrium constant for the reverse reaction. Okay, do you agree for the reverse reaction, Kc is going to be, for the reverse reaction, is going to be hydrogen iodide squared over hydrogen over iodine. But do you agree from this here, we know that inverse of this is equal to 0.02. Therefore, this has to be equal to 1 over 0.02. So we can just pop it in our calculator. We can go 1 divided by 0.02, and we end up with 50. So therefore, the Kc for the reverse reaction is 50. So you can understand that you don't actually have to do this whole calculation, as long as you understand that at equilibrium, the equilibrium constant is just going to be the inverse of what you worked out for the forward reaction. Okay, grade 12s, please make sure you understand how to do this. The best thing to do is go and try this again by yourself without actually, so pause it when the example comes up, try and solve it for yourself, and then go through the solutions when I'm doing it with you, and then see how you did. Okay.